Hello everyone, this is part 1 of my AMC12B review video for last year. And for this video, what I want to do is a bit different. I want to actually go at a real 75-minute pace. So I want to make sure that for those of you who actually hope to try all the questions in the paper, you know what that entails. How fast do we need to move to make a proper attempt at all the 25 questions? Now, this is not the goal for all of you, but it's always no harm to just find out and understand what are the demands and what are sort of the pacing strategies you would want to use. Now, since I want to go at the actual pace, I'll just give myself 1 minute to get in all the plugs that I want to. First of all, please don't forget to like this video and to subscribe if you want to see more AMC, SMO or Olympiad content. Also, if you would like to register for the AMC 12 or the AMC 10, you can still do so until October the 17th through our center. The details are in the form here, which is linked in the description below. Take note that for our center, we will be conducting the papers on paper, offline, although I know that there is also the online option. Secondly, also for our class, the classes will be from the 23rd to 27th October as well as the 31st to the 4th of November. Both weeks are the same, so you can just pick whichever one if you are interested to join. So this applies both for the AMC 10 and the AMC 12. The classes are conducted by myself physically at Serangoon, but also via Zoom if you prefer to follow from the comfort of your own home. Right, so I shall now get to the main purpose of this video, which is let's try to finish the paper in 75 minutes. Okay, it's about the 2-minute mark. I'm going to be explaining a bit less for these papers because I want to actually make sure that we can see the 75-minute pace. So question 1. This is a computational question. Absolute value x minus y just means difference. And so 2 and 3 difference is 1, 1 and 1 difference is 0. 1 and 2 difference is 1, 1 and 3 difference is 2, 0 minus 2 will be negative 2. So answer is option A. Second question, rhombus ABCD, P lies on AD such that BP is perpendicular to AD, AP is 3, PD is 2. So this means that the rhombus has side length 5. I can label everything as 5 and I get this right angled triangle over here. So area, 4 times 5 equals to 20. Question 3. How many of the first 10 numbers of the sequence 1, 2, 1, 1, 1, 2, 1, 1 and so on are prime numbers? Now, when you have such big numbers, there must be a simple way to test whether they are prime, and even divisibility tests don't seem to be very appealing because they're getting longer and longer. So I want to look for some sort of obvious factors. Now 1 to 1 I can say is 1, 1, 0 plus 11, so 11 is a factor. 1, 1, 2, 1, 1 is 1, 1, 1 and 1, 1, 1 stacked up, so factor is 1, 1, 1. 1, 1, 1, 2, 1, 1, 1 is also 1, 1, 1, 1, 1, 1, 1, 1 and also stacked up like this. So oops, I meant to say 1, 1, 1, 1 is a factor. So this will continue, which means that none of them are prime numbers, and the answer is A. For question 4, how many values of the constant k will the polynomial x squared plus kx plus 36 have 2 distinct integer values? That means that you are taking your roots by Vietas, their product will be 36. And I want to know how many possible values are there of k. K is negative of the sum. So basically, how many different values are there of the sum? So product is 36. I can just write down all the possibilities. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6 I cannot use because of the distinct value condition. So there are 4 values here, as well as the negatives, which will give you another 4 values. So total you get 8 possible sums. I know I don't need to actually add them because as they get closer together, the sum gets smaller, so I can save that few seconds there. Question 5. The point -1, -2 is rotated 270 degrees counterclockwise. This is just 90 degrees clockwise. About the point 3, 1, what are the coordinates of its new position? So -1, -2 is somewhere here, 3, 1 is somewhere here, and I want to rotate about this as the pivot. So I shall just look at the horizontal distance is 4, vertical distance is 3. So effectively I'm rotating this point 90 degrees, means that I'm just rotating the whole triangle 90 degrees. This is 3 and this is 4, which tells me that my diagram is actually a bit off. Right? This should be 0 and this should be 1 plus 4 is 5. So answer is B. Question 6. Now I see that I've got 1 to 1000 split into 100 sets of 10, and I'm asked how many of these sets contain exactly 2 multiples of 7. So there are sets of 10 elements each. If there are sets of 10 elements each, it means that there are 1 or 2 per set. So essentially, it's asking how often do you get 2 instead of 1. And I think I could actually just find a pattern mod 7 for which ones have 1, which ones have 2, but a slightly easier way would simply be to notice that I can count the total number of multiples of 7. Which is 1000 over 7, rounded down, is 142. So 142, you have got 100 of 1 or 2, which means that if they were all 1s, they are 100. So I must have gotten an extra 42 by switching them over to 2. So answer is option B. Question 7, Camilla writes down 5 positive integers. The unique mode, it's important, is 2 greater than their median, and the median is 2 greater than their arithmetic mean. Okay, so unique mode means that it needs to appear at least twice. So this is the median, assuming we put them in order. The mode is bigger, so it must appear twice, so which means that both of these are the mode. And I'll just call them x plus 2, x plus 2. The median is 2 greater than their arithmetic mean, so which means that the average is x minus 2. The sum is 5 times of that is 5x minus 10. These 3 are already 3x plus 4, which means that what's left is 2x minus 14. Now the mode is unique, which means that I need to split up the 2x minus 14 such that there is no other repetition. It says least possible value of the mode. That means that I want x plus 2 to be as small as possible, which means I want x to be as small as possible. But these are positive integers. So 2x minus 14 has to be more than 0, x has to be more than 7, which means I could try x equals to 8. But if x equals to 8, the sum is 2, and that would force both of these to be 1. And now that would also be the mode. So I don't want that. I try x equals to 9, the sum is 4, and I don't see anything wrong with this being 1 and 3. This would be 9, this would be 11, and so your answer is option D. Question 8. What is the graph of y to the 4 plus 1 equals to x to the 4 plus 2y squared in the coordinate plane? And we're given a lot of nice sounding graphs, so which means that this should actually be a nice equation. I see that there is a y squared. All of these are even powers, and also I see that y sort of belongs down there. So let's shift it over. Now this is a perfect square, which means that I get either y squared minus 1 is x squared, or y squared minus 1 is negative x squared. So this is y squared plus x squared equals to 1. That's a circle. It's the unit circle. This is y squared minus x squared equals to 1. That's a hyperbola. So therefore, the answer is option D. Now we're going at a 1 minute per question pace. I'm barely taking a break in between. If you're hoping to do all the questions, you need to be able to work so continuously. You don't really get a breather until maybe question 15 where you can say, okay, let me take a breath. So let's try to do that. Question 9. The sequence here is a strictly increasing arithmetic sequence of positive integers such that 2 to the a7 equals to 2 to the 27 times a7. Okay, that's interesting because it is basically an equation that only involves one unknown. And they are positive integers as well. So if they're positive integers, power of 2, power of 2, power of 2, it means a7 is 2 to the power of something. Let's call it 2 to the power of n. So this means that 2 to the power of n equals to 27 plus n. Obviously, we can just see that n equals to 5 will work. And anything more than 5, the left side is just going to grow super fast. So it cannot be any other value. And so actually a7 is 32. Now, the question kind of just glues two parts together because it now asks what's the minimum possible value of a2, which means that you're looking at the fact that it goes all the way down to a0. There is a common difference, which would mean that this is 32 minus d, 32 minus 2d. By the time you're here, you're 32 minus 5d. By the time you're here, you're 32 minus 7d. And I have to make sure that everything is positive integers. So that means that this is greater than 0. d is at most 4. And so if d is at most 4, a2 is at least going to be equal to 12. Question 10. Regular hexagon ABCDEF has side length 2. Let G be the midpoint of AB and H be the midpoint of DE. Now I can see these are opposite sides, so things should be not so bad. Now if you have trouble drawing a nice hexagon, just consider drawing a bunch of equilateral triangles and then just erasing the connecting lines in between. Right? Just like sort of put a center in if you want. This is G, this is H, and I want to know the perimeter of GCHF, which is very obviously going to be symmetric. I feel like I don't need to do anything more than just use the cosine rule because this is 2, this is 1, this is 120 degrees, and all four of these are the same. So I'll just use it on one side. Cosine 120 degrees is negative 1/2, so it cancels and you get 4 plus 1 plus 2 is 7. So FG is square root 7, and my answer should be 4 square root 7. Question 11. Complex number problem, and you should be able to see that these are definitely something roots of unity. Because of the root 3 over 2 minus 1 over plus root 3 over 2, and these are conjugates. So I'll just find one of them, and that should be enough for me to know where they are on my Argand diagram. Okay, so real, imaginary, minus 1/2 plus root 3 over 2 is somewhere here. And so this would be pi over 6 or 30 degrees. And so this would have argument 2 pi over 3 or 120 degrees. Now the other one, down here, this will have argument 4 pi over 3 or 240 degrees. And both of these mean that it will be third roots of unity. So we call this x and call this y. It just means that x cubed and y cubed are both 1. If you did not know complex numbers in exponential form or polar form, you could just have found a pattern and it would have taken you 3 steps. But this is a lot quicker since 2022 is a multiple of 3 from our divisibility test. Or if you're taking it last year, I'm sure you knew it was a multiple of 3. So that simply means that both of these are going to be 1. It will be 1 to the power of 674, it's still 1. So answer would be 2. Question 12. Kayla rolls 4 fair 6-sided dice. What's the probability that at least one of the numbers Kayla rolls is greater than 4 and at least 2 of the numbers she rolls are greater than 2? Okay, so for this one, you kind of can see that all of the options have powers of 3 in the denominator, because essentially the cutoff points are 4 and 2. So you can treat it as if the dice really are just going to be 1, 2 are glued together, 3, 4 are glued together, 5, 6 are glued together, and it's sort of like they're in 3 categories. What's the probability that at least one of the numbers Kayla rolls is greater than 4 and at least 2 of the numbers she rolls are greater than 2? So I think what I'll do is to do a complementary counting. I subtract off the probability that all of them are less than or equals to 4. I subtract off the probability that at least 2 of them are greater than 2 does not happen. And if this does not happen, it means that at most one number is greater than 2. So at least 3 numbers are less than or equal to 2. And then I add back the probability that both happen. Okay, so the chance that all of them are at most 4 is 2/3 to the power of 4. The chance that at least 3 of them are at most 2, you have got sort of like 3 of them in category A and something else. This can happen in 4 different combinations depending where you put your category A, as well as the one where all of them are in category A. So this would give me 4 combinations of 1/3 cubed times 2/3 and 1 combination of 1/3 to the power of 4. Now I add back the probability that I have subtracted off twice, which is all of them are less than or equals to 4, meaning they're all in category A or B, and there are at least 3 of them which are less than or equals to 2, which means that they are either AAAB with the 4 rearrangements of this, as well as AAAA. So I just calculated that, but now I need to put it back. Never mind. So this is 4 times 1/3 to the 4 and another 1/3 to the power of 4. Okay, so let's cancel off the 1/3 to the power of 4 and then just do a subtraction. Minus 8/81 plus 4/81, and with this I get myself 61/81, which is option D. Now in practice you should probably check this. If you want to check this, one way to do it would be to just simply consider one particular arrangement and just see whether you have accounted for it exactly 0 or 1 times depending on which one you want. For example, just look at something like AABC and check AABC is something that satisfies the condition, so you should not have subtracted it off. And if you just pick one or two of these and check that, it should be fine. Question 13. Diagram below shows a rectangle with side lengths 4 and 8 and a square with side length 5. 3 vertices of the square lie on different sides of the rectangle as shown. What is the area of the region inside both the square and the rectangle? So this is a 4 by 8 rectangle, and by the looks of this, I don't really care about the 8, but I somewhat do care about the 4, right? Because it doesn't even use the whole of the width here, so I never use the other side. Okay, so let's see. I'll label all the 5s first. This is a 4, and so this would be 3. Now I'm seeing that all of these triangles seem to be similar to each other. Which is great because it means that, in fact, this is a congruent triangle. And the rest of them, I can find the lengths just by similar triangles. And if I know they're similar, I don't even need all of them because I can jump straight to this one. This is 5 over 4 times of my classic 3, 4, 5 triangle, which means that this would be 15 over 4, and the area of this triangle is 75 over 8. So my area inside both the square and rectangle is 5 squared minus 75 over 8. This is 9 and 3/8, so I get 15 and 5/8. Okay, now I'll take a quick exhale, because at this point, after 13 questions, you should most likely have, if you're all correct, already made it into the AIME. 13 questions gives you 96 points. 96 points has been enough for the AIME qualification in most of the past few years for the AMC12. Of course, that's assuming everything is correct, but we are making excellent time. That was about 20 minutes in and we are halfway through. I'm not exaggerating when I say this is the pace that you need to go at if you hope to finish, because difficulty just spikes very quickly. So let's continue. Right? Keep your pace up, maintain your stamina, don't let your brain drift off, but you can reward yourself, let's say after you reach 5 questions, 10 questions, or some nice checkpoint with just like a 30-second breather just to rest your arm and rest your brain. Here, I'm just catching my breath because I've been talking for 20 minutes. Okay, so I have parabola here in theory, but I only really care about A, B, and C. So B, the y-axis at point B, x equals to 0, this will be negative 15. Now, the x-intercepts, I just need to factorize this. They've been quite nice, right? This is not a very difficult thing to factorize. So A and C, I don't know which order they are in, it does not matter. But I will just put it here. This is not even actually to scale. I've got my 5 and 3 mixed up, but never mind. Now, I want tangent of ABC. I think the easiest way to do that would be to just use my compound angle formula for tangent, right? Because tangent alpha is opposite over adjacent is 1/3. Tangent beta is opposite over adjacent is 1/5. Now I know that this diagram is truly abhorrent. You have to, I guess, give and take a bit. We are in a rush. Don't have time to draw nice diagrams. So tangent alpha, tangent beta, 1 minus tangent alpha, tangent beta. Third, a fifth is 8 over 15 minus over 14 over 15, and so this is going to give you 4 over 7. Question 15. one of these numbers is not divisible by any prime number less than 10, okay? That's just 2, 3, 5, and 7, and a quick glance tells me I don't have to worry about 2 because they are all not divisible by 2. Which is it? I can just test 3, 5, and 7. I don't think I need to be particularly clever about this. So mod 3, 2 squared is congruent to 1, right? So which means that my options, if it's an even power, it becomes just 1. So I get 0, 0 plus, so I get 1 plus 1 is 2. This odd power will be 2 mod 3. So 2 minus 1, 2 plus 1, and then this is essentially gone mod 3. Odd power, again, this is 1. Sorry, no, this is not 1, this is 2. But that does not matter because I want to find which one is not divisible by any of these, so that eliminates 2 options. Now let's go on to mod 5. Now for mod 5, my 2 squared is 4 is negative 1 mod 5, and 2 to the 4 is 1 mod 5. So 2 to the power 606. 606 is divisible by 2 but not 4. So which means that it will follow the first one, negative 1 plus 1 is 0. This will be 607 is 3 mod 4, so it will become negative 2 minus 1 is negative 3. I don't need to calculate part D. Part E, this is divisible by 5, right? Because it's going to be 2 to the 607 plus negative 2 to the 607. So this is 0, which means I can eliminate options B and E, and I get to say the answer is C without even checking 7. So that's a nice time savings gained there. Question 16. X and y are positive real numbers such that x to the power of y is 2 to the 64 and log 2x to the power log 2y is 2 to the power of 7. What is the greatest possible value of log 2y? It says greatest possible value, but it doesn't say anything about integers. So I think this is more of an algebraic greatest possible value, not like a list of possible values kind of greatest possible value. So I need to figure out how to handle this. And I think what I want to do is I will just let a equals to log 2x, b equals to log 2y. Personally, I am always a bit partial towards using exponentials rather than using logarithms. So maybe it's easier to see that way, and also because I want the largest possible value of b, right? So that allows me to focus a bit more. Now x to the y has become 2 to the a to the 2 to the b equals 2 to the 64. So a times 2 to the power of b equals 64. Second one is just a to the power of b is 2 to the power of 7. Okay, so I want b to be as big as possible. I feel like one option is just to try everything, right? I don't see why that would necessarily be wrong. Let's see, right? So actually I don't need to try everything. A times 2 to the b is 64. This is 2 to the power 6 again. So a is 2 to the 6 minus b. And okay, so this is just normal algebra. 2 to the 6 minus b to the power of b. So 6 minus b equals to 7. If you know yourself that your handwriting is particularly bad at some things like 6 and b looking exactly the same, just be a bit more self-aware of such issues. Okay, so this one, I prefer to complete the square when I can tell it cannot be factorized. So b will be 3 plus minus square root 2, and the larger possible value will be 3 plus square root of 2. Question 17. Now I've used the AOPS wiki version of this, which has a slightly messy kind of rendering because I just copy pasted it. So sorry about that, but it's also a warning. If you're taking the paper online, sometimes the formatting is a bit wonky. So if you're getting a bit of OCD discomfort at like all the numbers floating all over the place, I get it. But if you're in such a hurry, honestly, it doesn't even occur to you, I believe. Okay. How many 4x4 arrays whose entries are zeros and ones are there such that the row sums are 1, 2, 3, 4 in some order and the column sums are also 1, 2, 3, 4 in some order? For example, this array satisfies that condition. Now what I'm thinking about is that this is quite restrictive because of the 4s, meaning they're all 1s. So my question is there a way to solve something like this? And if the answer is yes, then all permutations of 1, 2, 3, 4 in rows and columns must also work, right? So if let's say for example this works, and then 2, 1, I would just swap the first and second row. So if this works, then it should all work. And if the answer is no, then they should all not work, and there will be 0. If yes, then it gives me 4 factorial squared times whatever, and 4 factorial squared is 576 already. So the answer has to be 576 without even me worrying about how the grid works. And again, I shall move on from here, because I think this is going to take a bit longer to read, right? Yeah. Sorry, Microsoft Word thinks that I've spelled American English is wrong, so neighboring is marked as a spelling error. Let's read. Each square in a 5 by 5 grid is either filled or empty and has up to 8 adjacent neighboring squares, where neighboring squares share either side or corner. So they're just describing normal stuff, and then it says that any filled square with 2 or 3 filled neighbors remains filled. Any empty square with exactly 3 filled neighbors becomes a filled square. All other squares remain empty or become empty. So this is like some of you know Conway's Game of Life. This is like a modified version of that. So if it's filled and it's 2 or 3, it remains filled. If it's empty and has exactly 3, it becomes filled. So here, empty with exactly 3 would be only this square and this square, and then filled with exactly 2 or 3 neighbors is this square. So that is how you end up with this sample transformation. The question says the 5 by 5 grid has a border of empty squares surrounding a 3 by 3 subgrid. How many possible initial configurations will lead to a transform grid consisting of a single filled square in the center after a single transformation? Okay, so a single filled square, right? So there are 2 options, right? The first case is that the middle square was already filled. Now let's go with let's go with empty first, right? Because if it's empty, then that is more constraining. So let's say that it was empty. Now if it's empty, then for it to become filled, I need exactly 3 neighbors. So exactly 3 neighbors, and I need to make sure that nothing else got exactly 3 neighbors. So let's see how this will look like. Now I'm going to use a bit of Rubik's Cube terms to say these are my corner pieces and these are my edge pieces, so that I can sort of distinguish my cases more easily. Now if there are 3 edges like this, that would not work because this would also have been filled. Now if there are 3 corners, so 3 corners, are there any empty squares with 3 neighbors other than the middle? The answer seems to be no. So that gives me 4 ways already, right? Now the next case would be 2 edges, 1 corner. Now if the 2 edges are next to each other like that, then I am thinking that this would work because my filled squares only have 1 neighbor, and there does not seem to be anywhere else that is empty having 3 filled neighbors. So this could be done again in 4 ways if the filled squares in the edges are next to each other. If the edges are opposite and you did something like this, then this would also end up having been shaded afterwards. So I don't want that. So it's just 4 ways. Now the last one is 1 edge and 2 corners. And if the corners are next to each other, again I don't want this because that will also have been filled. something like this should work, right? So that gives me another 4 ways if the corners are next to each other. If the corners are opposite each other, then again, any one of these ways should also work, right? There are 4 choices for the edge. So another 2 times 4, because I can choose which 2 corners, and then all 4 of the edges would have been fine. So at this point, I have got myself 20 ways. The good news about 20 ways is that it's none of the options, so I can now look at what if the middle square was already filled. And I know there must be something because it's none of the options. Now if the middle square is already filled, then I want 2 or 3 filled neighbors. So I think I can go through the same cases again. 2 corners, then this would also end up being filled. 2 opposite corners would work. So there's 2 ways you can do this. If there is a corner and an edge, this will not work because this would end up staying filled. This will not work because this will also end up being filled. If you have got 2 edges, then it will not work because in this case this will end up being filled. In this case this will also end up being filled. So I only now need to check if I've got 3 things, and I feel like this is going to go the same way as before. If I've got 3 edges, then this will end up being filled afterwards. If I've got 2 edges and a corner, then yeah, these would definitely end up remaining filled regardless. If I did this, then one of these edges is going to end up filled regardless. If I have 1 edge and 2 corners, this will end up being filled, and I'm starting to think there's nothing else, right? If I did this, opposite corners, it will also end up being filled at the end. And what other case is there? I think I have covered almost all the cases already. 3 corners I have not covered, but 3 corners definitely does not work. So that seems to be all. After a lot of boring casework, the answer is 22. Now, if you were trying to optimize for time, you should probably skip this question, in the sense of trying to finish 20 questions. If you want to finish everything, you have no choice, right? And this is why we saved up all the time from earlier on. This question alone took us 5 early or 6 early questions. Okay, question 19. In triangle ABC medians AD and BE intersect at G. So this is the centroid. I'm not even sure what I want to happen, so I'll just draw it first and we'll see. And triangle AG is equilateral. Okay, great. I feel like as if, since it says cosine, this is a trigo thing, I feel like I can live with this actually. I'm not going to be too fussy. I am going to actually try to make things work. So these are equal somehow. Let's pretend. And what is supposed to happen is I want to know what is angle C. So there is some angle C that makes this happen. I'm not terribly surprised by that. Let me see what would be the best way to go about this. Well, this E is the midpoint, right? So this is also equal, which means that AGC should actually be perpendicular. And this is very confusing to look at. So maybe I am going to draw AGC as that now instead, and I'll start with AGE and C. Now if I start with AGE and C, I feel like this may not be very hard anymore, because I mean, this is guaranteed if I make everything work. Now I shall extend AG extend GE, and what I need is for me to extend it such that I end up with D being the midpoint of BC. So I think something like this could work. Because C is not going to be a special angle. C is not going to be a special angle based on what I'm asked to find. Okay, and I'll call this all X. Now, based on the properties of the centroid, I know it's 2:1. So this is half X and this is 2X. I know that this is going to be square root 3X, which again means that I have got not much left to say. This is going to be, let's throw away all the X, shall we? I mean, just let it be 1. Because I need cosines, so I think it's easier to just drop all of that away. And this will be square root of 3 plus 1/4, which is square root 13 over 2. Okay, so I've got everything down. I think I can just use my cosine rule now on this triangle here and just see what I get. Actually, I think I don't need to, because I already know that this is a 30-degree angle. So cosine 30 plus theta makes more sense. Cosine theta is root 3 divided by root 13 over 2. And this is 1 over root 13. Okay, so this is 3 over root 13 minus half times 1 over root 13. Okay, so this looks good. At least it's going to appear in the correct form. So it's 5 over 2 root 13, which is 5 root 13 over 26. So add those three numbers together, I get 44, which is thankfully an option, so I trust that I have not messed up. Now at 40 minutes, right, so it means that even going at this speed, you have about 35 minutes for 6 questions. I haven't stashed that much time as I hoped. Px be a polynomial with rational coefficients such that when Px is divided by this polynomial, remainder is x plus 2. When divided by x squared plus 1, the remainder is 2x plus 1. Now you can think of this almost like a quasi-modulo arithmetic question. It means that there would be a unique P modulo the product of these two things, is what it would say, because these two polynomials are essentially co-prime. Now, what I'm trying to do though is that I want to get them to meet at a certain degree. So I ask myself, can I meet at degree 1? That's impossible, because if I get them to meet at degree 1, then I certainly would not be able to use this at all. Can I get them to meet at degree 2? Well, if I meet at degree 2 means I have to use a constant multiple of this and a constant multiple of this that must be the same because of the leading coefficient x squared, and that would not satisfy the constant term. Now I know that I don't need degree 4 because I have a unique P modulo a degree 4 thing, so I'm just left to try to get a degree 3 thing that works. So I will use this. And I'll write it as ax plus b and ax plus c being the multiples that I use. And I'll just expand it and see what happens. Right? So coefficient of x cubed is ax cubed here, that matches. X squared coefficient, I get b plus a. x squared coefficient here, I just get c. X coefficient, in fact I can just cancel off a little bit here just to make it a bit nicer. So the x coefficient would just be a plus b again. And this one would be 1 plus a. Okay, great. That gives me b is 1. And the constant gives me 1 plus b is equivalent to c. So c is 2 and a is 3. Now let's just check, right? What does that actually give me for p? So 3x plus 2x squared plus 1. I believe I get this, and let me just double check since I did some cancellation earlier, which maybe I should not have done. Okay, 3x cubed. Looks like 4x squared. Did I mess up somewhere? Or am I? B is 1. Okay, this is what happens when you speed too fast, right? You now get some slightly dubious things. Let me just double check whether I've messed anything up. I want a plus b to be equal to c. My goodness. I have totally conked. A is just 1. Sorry, so this is just x cubed plus 2x squared plus 3x plus 3. This is x cubed plus 2x squared plus 3x plus 3. Okay, so that works, and the question asks for the sum of squares of coefficients. 1 plus 4 plus 9 plus 9 is 23. Great. So let's just take time. That is 45 minutes, right? If you look at the timestamp. So which leaves us for 30 minutes for the last 5 questions. I'm going to try to do the last 5 questions in 30 minutes in the next video, but for now, this is the speed that you want to take into an AMC12 if you would like to try all the problems. Thanks for watching, and see you soon in the next part.